We will be presenting our final project on LAPD crime data analysis and forecasting. Our project focuses on understanding how crime patterns in Los Angeles vary across time and space, and how we can use time series models to forecast crime activity at an hourly level. In particular, we compare two forecasting approaches, Prophet and Sarima, and demonstrate how the results can be deployed into an interactive system that allows users to query crime forecasts for a specific location and time.
Crime patterns are highly dependent on both time and location. Understanding when and where crimes occur can support better planning and resource allocation. However, hourly crime forecasting is challenging due to strong noise and randomness. In this project, our goal is to analyze the spatial-temporal patterns of LAPD crime data, focus on hour-level temporal dynamics, compare Profit and Sarima for hourly forecasting, and evaluate model robustness across all areas and the focused central area.
We use LAPD crime data from 2020 to present with about 1 million records. Due to the data size, we processed it using PySpark. The dataset includes time, location, and crime-related categorical variables. Because the data is continuously updated, recent years may be incomplete, so our analysis focuses on overall time trends and spatial patterns rather than raw year-to-year comparisons. For the data cleaning, we standardized the key fields such as victim, weapon, and location information, and removed invalid geographic records with zero latitude or longitude. We also normalized the date and time formats and engineered hour, weekday, and quarter features for time analysis. After cleaning, we retained about 99.8% of the original data. Um, we generated a heat map for understanding spatial distribution of crime. The heat map shows a strong spatial concentration of crime across Los Angeles. The most significant hotspot is located in the central or downtown LA area, with much higher intensity than surrounding regions. Because of this, we focus our later analysis on the central area. For the time trends, from 2020 to 2023, monthly crime levels generally increased. The drop in 2024 to 2025 is due to incomplete reporting, not a real decline, so those years are excluded. Hourly patterns in the central area show a clear daily cycle, with peaks around midday and early evening.
We compare two time series models, Profit and Sarima. Profit decomposes the series into trend and seasonal components and handles non-stationary, noisy data well, making it suitable for hourly crime patterns. Sarima is a classical autoregressive model that requires stationarity and careful parameter tuning, and serves as a strong baseline. We evaluate both models using RMSE and MAPE, and the results show that Profit outperforms Sarima in both metrics. For all areas, Profit successfully captures the strong daily cycle of crime activity, with forecast peaks and troughs closely aligned with actual values. Short-term forecasts are smooth yet responsive, preserving overall temporal structure while avoiding overfitting to hourly noise and extreme spikes. Aggregated visualizations, including daily averages, show high consistency between actual and predicted patterns, which supports the lower RMSE and MAPE achieved by Profit. We further analyzed the central area to evaluate spatial robustness. Compared to all areas, Central has lower average hourly counts, which leads to higher variance and noisier patterns. Despite this sparsity, the same daily temporal structure still exists. Profit continues to recover the underlying hour-of-day pattern and remain stable, demonstrating robustness when applied to a spatially concentrated and more challenging subset.
Since Prophet is doing better than Sarima, we deployed an interactive forecasting system for Central Los Angeles based on the Prophet model, which we identified earlier as the area with the highest crime density. And the demo shows how a user can query the predicted crime frequency and the crime rates for the top 5 crime types for Central LA at any given hour. Users can select a date and an hour. The system then retrieves the forecast generated by our model. For example, here we select August 22nd, 2023, and in the hour of 8 p.m. to 9 p.m., the crime frequency forecast is 2.77. And if we change the hour to 6 p.m. to 7 p.m., the forecasted crime rate is 8.28. And we change the date and time to August 25th, 2023 at 3 p.m., the forecasted rate is 2.89. And where our current system demonstrates how hourly crime forecasting can be operationalized for Central Los Angeles, there are several directions for future work that could further enhance both the analytical depth and practical usefulness of this project. First, our framework can be extended beyond Central Los Angeles to cover additional districts across the city. And since the data pre-processing and modeling pipeline is modular, the same approach can be applied to other areas. Second, while we currently forecast overall crime frequency and estimate the top crime types based on historical distribution, future work could involve both building separate prediction models for major crime categories. And this will allow us to capture crime type specific temporal dynamics, such as different daily or weekly patterns for violence versus property crimes. And another extension will be upgrade this to real-time forecasting once the LAPD crime database has fixed their real-time feedback. And overall, our project demonstrates how large-scale crime data can be analyzed, modeled, and deployed into an interactive forecasting system. And thank you for listening.